and with efficiency. So for each of the team members, they have a value of speed and efficiency. We want to return the maximum performance of this team. Since the answer can be really large, it's gonna be modular 10 to the power of 9 plus 7. And for the speed, it is the sum of them. For example, if this k equals to 2, it means we're gonna choose at most 2 members, but we need to return the maximum performance. So the maximum performance is calculated by sum of the speed. For example, if we choose the first 2 elements, first 2 members, it's gonna be the sum of the speed. 2 plus 10, it is 12. And the minimum of the efficiency, it is gonna be 4. So 4 times 12, it is 48. So this is just an example. So the final answer is this 10 plus 5. This 10 and this 5. And we're gonna choose the minimum of this 4 and 7. So it is 4. So 15 times 4, it's gonna be 16. If you understand the question, let's try to solve the problem. Now let me just copy the array because we have a speed and efficiency. We cannot solve the problem by brute force like n square. We have to solve it by n log n time because n is 10 to the power of 5. Now let's try to use those 2 arrays. So first of all, this is the speed, and here gonna be the efficiency. So let's find some patterns of the 2 arrays. So as you can see, for all the speed, so for example, this speed, there is always efficiency mapped to it. So for the efficiency, so for example, if we choose 2 members, the efficiency must be the lowest, and the speed must be sum of the values. So this means by some data structure, if we can find the lowest efficiency, so for example, currently if this lowest efficiency is 9, we can only choose this 9 because for all other values it is smaller than 9. So what is the speed? So the speed is 1. So what is the result? The result is 9 times 1, it is 9. So for the second one, so for the next step, what is the efficiency? What is the lowest efficiency can we choose? Maybe it is 7. If we choose 7, so the lowest efficiency is 7. So if the efficiency is bigger than 7, it's gonna be 9 because 9 and 7 it meets the at most of 2 members. K equals to 2 because So we're gonna choose 7 and 9. Currently the lowest efficiency is 7. But what is the sum of the speed? It is 1 plus 5. So what is the result? The result is 7 times 5. It is 35. Now it seems that we have some kind of a pattern to solve the problem. So for the speed, if we find a lowest efficiency, for example this 7, we can always choose the maximum speed. So currently with 1 and 5. So for the next one, if we choose the lowest efficiency 5, now we have a speed of 2. It means we're gonna use the speed 2 and 5. We don't need this 1. So this 1 will be popped out. So the lowest efficiency is still 5. But the sum of the speed will 2 plus 5. So the result will be 35. Now let's rearrange the array to make the problem even more simpler than you expected. Now we're gonna zip the efficiency and speed in a tuple, according to the decreasing order of the efficiency, because we're gonna always choose the efficiency, the lowest efficiency. So we're gonna sort it in decreasing order, because this after sorted in decreasing order, we're gonna check the efficiency in O1 time. And we're gonna check the lowest, we're gonna check the speed also in log n time. After looping through the array, it is n loops, it is O(n) time, and for the minimum value, we're gonna use the log n time because we can use a min heap. So the time complexity will be n log n. Now let's try to choose more examples. First of all, we're gonna zip the efficiency and speed. So for example, we're gonna zip 9 and 1. It is here, 9 and 1. And next, we're gonna put the lowest efficiency 7 and 5. Yeah, and we're gonna sort the array in decreasing order. And what about next? It's gonna be 5 and 2. Yeah, I'm gonna just use some examples to explain it. After that, I'm gonna code it up, because if I just coding, maybe you don't understand. Yeah, so for the next, it's gonna be 4 and 10 efficiency and speed, and the next gonna be 3 and 3, and let's finish the last one. It's gonna be 2 and 8. Yeah, now let's analyze. So for the first one, we're gonna choose the lowest efficiency 9. It means there's no efficiency that is bigger than 9. So first of all, we're gonna just choose 9. So currently the lowest efficiency is 9, and what is the speed? So the speed is 1. So the final result would be 9 times 1, and it's gonna be 9. Yeah. Now we're gonna choose the second one. So we're gonna loop through this array. So the second one would be 7. So currently the lowest efficiency would be 7. Yeah. If the lowest efficiency is 7, and what gonna be the speed? So the speed gonna be 1 plus 5. It's gonna be 6. Yeah, because at most we're gonna have k different engineers. Yeah, engineers. So it's gonna be 7 times 6. It's gonna be 42. So 42 is bigger than 9. So we're gonna choose 42. Yeah. Now we're gonna choose the third one. But if we choose the third one, we've already exceeded the number of engineers, because maximum is k. Now it is 3. Yeah. But what is the lowest efficiency currently? It is 5. Yeah. But there are 3 members. We need to, first of all, we need to add this speed of 2 inside our min heap. So currently min heap have 1 and 5. Now we have 1, 5, and 2. So the sum of them will be 8. But we need to minus the minimum value. We can use the min heap to pop the minimum value out, pop this one out. Yeah. So 8 minus 1, it is 7. So 5 times 7, it is 35. So currently the maximum is still 42. So for next, we're gonna check this 4 and 10. So currently this 1 and 9 has already popped out of the heap. I mean this value of 1. Currently we have 5 and 2. Now our lowest efficiency is 4, because we're gonna check this one, and we're gonna put 10 inside the min heap, and we're gonna use 5 plus 2 plus 10, it is 17. Yeah, and we're gonna minus the minimum value, because it exceeded the k. K is 2, currently it is 3. So 17 minus 2, it is 15. So 4 times 15, it is 16. Yeah, I'm gonna not prepare other examples like the last 2 examples, but currently the 60 is the maximum value, so I'm gonna return this 60. Yeah. Now let's just implement all my solutions in the code. Yeah. So let's just sort out the efficiency with the speed. So for ES in sorted, we're gonna zip the efficiency and the speed. Yeah, and it's gonna be reverse order, so reverse should be equal to true. I'm gonna prepare a result and the total value, because I'm gonna check the total value of the speed, and I'm gonna prepare a mod. So the result would be starting from 0, total also 0, and the mod is 10 to the power of 9 plus 7. Yeah. Now we are going to check this efficiency and speed. So first of all, we're gonna check the total value. So the total should plus equal to the speed. Yeah, and what's gonna be the result? So the result would always be the maximum of the result with efficiency times total. Yeah. Finally, we're gonna return this result. Yeah. But before that, we need to check if the length of the min heap exceeded this k. If it is more than k, it means we need to pop out something. Yeah. So at the same time, we're gonna prepare a priority queue. Yeah. So after we use total to plus the speed, we need also use the min heap. So we're gonna push the value of the speed inside of the priority queue. Currently, for example, we have a value of speed of 1. Next, we're gonna have a speed of 5, and next we're gonna have a speed of 2. It's gonna be like that. Yeah. So we're gonna check this the length of the priority queue. If it is more than k, it means we need to pop it out. Yeah. So we're gonna pop out the mean value. We're gonna use a heap pop with the priority queue, and the total should minus this minimum value. Yeah. So this is the entire code. As you can see, that is quite easy to write, but it's really difficult to think about it. Actually, this is a pattern. We call it sort plus priority queue, and there are a lot of Leetcode problems like this pattern, and you have to practice 2 or 3 similar problems, and then you can grasp this kind of a pattern. It's difficult to think about it. As you can see, the rating is really high. It's nearly 2100. Yeah. So the idea is after sorting the array, we have the lowest efficiency. So after looping the sorted array, we always get the lowest efficiency. If we get the lowest efficiency, we just need to check the total value. So the total value of the speed, we can use our min heap to get the total value. So currently, total value will plus all the speed. If it is more than k, it means we're gonna pop it out, and the total value would be minus this minimum value. Yeah. And because it is at most k value, even we have only one value. For example, we're gonna first check this 9 and 1, and we got a result of 9. It is still a possible result. And then we're gonna have 2 values, and for others still we're gonna have 2 values. Yeah. And why we need to have 2 values? Because currently, for example, we're gonna take 9.1 first, 7.5 secondly, and currently the lowest efficiency is 7. But for the final result, this 7 is fixed. So 7 times 5 is 35. But 7 times 5 plus 1 gonna produce a larger value. So that is why we've always choose, if it is possible to choose k values, we always choose k. Yeah, otherwise we have to choose less than k values. For example, the first one, we can only choose 1 value, but for the second one, we can choose 2 values. And also why we push the third value inside, we can still choose 2 values, and also for the others. Yeah. Now let me just run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, I think I forgot to modular this mod, but let's just wait. Yeah, I forget about it. I always forget about the modular value. Yeah. Yeah, let me. I think I need a refresh. Let me just copy these areas in case if it is not saved. Let me refresh and submit again. Otherwise, it would take a long time. At the same time, let's analyze the time complexity, because we have this k and this n. And here we've sorted this array, and it is n log n time. And here we used the min heap. The maximum, the length of the heap gonna be k. So here it's gonna be nk. So the time complexity is n log n plus n log k. So this is gonna be the time complexity. Since this k equal to similar to n, because it is a maximum to 10 to the power of 5. So the final time complexity, we can say it is n log n. That is why it can pass for Leetcode. Yeah, I have to wait for a few seconds to make sure that it works. So currently the networking problem. Yeah, I have to run it again to check if the network is okay. I'm not sure. Let's just check. Yeah, I think there is a networking problem which influences. Yeah, uh, yeah, it is not working basically. Uh, yeah, let me refresh again to check. So there's no connection. Yeah, maybe I needed to use yeah, another website, the .com website of Leetcode. Maybe that's gonna work. Yeah, because normally for the CN in the China, it's gonna be really slow for me because currently I'm not in China. Yeah, I have to. Maybe I'm gonna. Yeah, I'm gonna use another website to just submit the code to check if it works. Yeah. Uh, yeah. Let me just copy the code from it. Yeah. Definitely here gonna not work. Now let's try again. Yeah, now it seems it works. Now let me just submit it to check if it can pass. Yeah, as you can see it passed and it's pretty fast. The time complexity is n log n plus n log k. Thank you for watching. See you next time.